Hello guys, in this video we'll be learning about implementation of 2D rotation using OpenGL. So we'll be addressing this problem statement. Create and rotate a triangle about the origin and a fixed point. So as we know, we were able to derive matrices for two rotations. One is rotation around the origin like this. So one is that. The other one is around a fixed point, something like this. Or if this is the fixed point, we would get like this. So there are two kinds of rotation. One is around the origin and the other one is around a fixed point. So in this video, we'll be learning about how to do both of these rotations using OpenGL. So before that, this is an example triangle that I'm considering in my program. So the coordinates is from see, though this is 2D, since I'm considering homogeneous coordinates, I am considering the third coordinate homogeneous coordinate also, and that I am keeping it at 1. Now this is 200 comma 100, this is 400 comma 100, and this is at 300 comma 300. This will be our original triangle, and we would want to rotate it around the origin as well as around the fixed point. Now what will be the input? See, this triangle, I have hard coded it in my program to consider this triangle. The input would be the angle of rotation. So if I give 90°, it would rotate around the origin by 90°. However, if I want to rotate it around a fixed point, then I would take user input as the fixed point as well. So the overall user input from for this program would be theta, that is the angle of rotation, as well as the fixed point around which the rotation has to take place. The fixed point can be anything. Okay, the fixed point can be this or this or this, or the centroid of the triangle, or some other triangle point. For example, we can consider 100 comma 150 as fixed point. At that time, this object would rotate around this, so it will come over here if we take it as 90°. So if we rotate it around origin, then it would go somewhere here. Right, so fixed point, you can take it as anything. Around that fixed point, this rotation will happen. Now let's quickly see the output of this program, and then we'll dwell into the code of this program in OpenGL. Now this is the program. As I already told you, it is asking me a rotation angle. I am giving it as 90. I'll give it as 200 and 100. See, this is the original triangle, the triangle in red. This is blue triangle, is a triangle which is rotated around this points 200 and 100, around this. And this green triangle is a triangle which is rotated by 90° around the origin. Here I have put a small red dot at the origin just to give you an idea of where the origin is. See here, from this point to this point, you can kind of have you can see there is 90° angle from this point to this point as well. If you see from this point to this point as well, it is 90°. Right, so that's about the output of this program. So we'll get started with the code. So I have defined my triangle like this, float triangle, 3x3 matrix, a two-dimensional matrix I have taken, and then the first row gives the x-axis of all 3 points, The second row gives the y-axis of all 3 points, and the third row gives me the z-axis of all 3 points. So the first point is 150, 200. Okay, in this we have taken in the slides it's different. Or here, see it, I have taken 200 comma 100, 300 comma 300. So that's this 200 comma 100, 300 comma 300, and the other one is 400 comma 100. All three of them all 3 points z-axis is 1. It's not actually z-axis, this is h-axis. I would put it as homogeneous axis. Now, so this is my main program. I am taking my command prompt arguments, and then I am initializing OpenGL, and then I am setting up my display mode. Since this is a 2D simple program, I am using single buffer, and then I am using RGB buffer. I am taking my window size as 500 cross 500 at position 0 comma 0, and my title bar or my output window is named by title triangle rotation, and this creates the window. I am giving a display callback function which is responsible for me to display my output, and then I am calling my init function which sets up my scene, and then this is the main loop which keeps repeating this main looking for events so that it can call appropriate callback function whenever an appropriate event occurs. Now this is my init function, the scene. I have taken the scene from minus 500 to 500 and minus 500 to 500. So meaning to say, if I have my output window something like this will be my minus 500, and this is my 500. Similarly, this will be my minus 500, and this will be my 500. So obviously this origin is in the center, so I would get my triangle somewhere over here in the window. So that's how I have set up the scene. I'm loading the projection matrix, and then I am setting up my ortho projection parameters. So that is my scene, and then I'm loading back my model view matrix. This is a basic display function. So this basic display function, we are clearing the background color. We are setting the background color to white, and then we are clearing the background color using this. So then I am taking the foreground color as red, and then I am calling a function called as draw triangle, which we'll see what it is in a while. And then I am using GL flush to flush the output. Now, this was my initial, declaration of triangle matrix, and then I am using GL triangles. And GL triangle is a function which actually writes this triangle. So it takes x as 0 comma 0, that is this, and then 1 comma 0, that is this. So it combines this value and this value and forms x and y of first point. It combines 0 comma 1, that is this, and then it combines 1 comma 1, that is this. It combines this value and this value as x and y for the second point, and so on for the likewise for the third point. It combines this and this. Now since we are doing it in 2 dimension, we are only giving it as x and y, and we have it as 2 float, that is 2ef, vertex 2ef. So right now if I execute this function, it would only draw one rectangle in red color. So this red color triangle is my original triangle. Now, so this much was to draw my original triangle. So I have cleared my background, then I have drawn my original triangle. After that, I am supposed to rotate this triangle. 0 comma 0 is what I'm passing. I'll tell you what this 0 comma 0 is. I am selecting green color and I am drawing draw rotate triangle. So we'll see what this, so this function is actually function which is responsible for rotating the triangle that we have here, and this function is responsible for drawing the rotated triangle. This function is responsible for drawing the original triangle. So that's the idea here. So our idea here is to rotate around the origin. So I am passing 0 comma 0. 0 comma 0 is not actually here. What I am passing is not the origin values. I'll tell you what those values are. So this is my rotate function. Rotate function takes two parameters, m and n. What are these m and n? If you see here, this is the matrix for rotation around origin, and this is the matrix for rotation around fixed point. XR and YR being my fixed point, right? Now, so this matrix is derived by negative translation and then rotation and then positive translation, correct? Now, in this function, I am going to build my rotation matrix depending on whether I am rotating around the origin or rotating around the fixed point. So what is the difference between these two? The only difference is these parameters, right? These two values. The rest everything is same. So what I'm going to call is I am going to use m here and I'm going to use n here. So my m and n value actually represent this. So if since I pass 0 0 while calling GL rotate, R rotate here, the 0 0 is taken by m and n, and the first value 0 comma 0 takes cos theta, and then the second value 0 comma 1, this takes minus sine theta, and then this takes m, and then this takes sine theta, this takes cos theta, and 1 2 takes n value 0 0 1, and then I call a function called as multiply. So over here what I have done is I have used, constructed rotation matrix. That's it, nothing else. My rotation matrix is to be defined or initialized before using this function. So I have initialized it to 0 0 0, declared it, and then initialized it to 0 0 0. Now see, if I want to do rotation around the origin, I have passed m and n value as 0, and thereby this value for around the origin takes value as 0 and 0. So the rotation matrix will be this one. Now, if I want this scene to change, if I want this rotation to be around fixed point, all I have to do is I have to calculate this term and assign it to m, calculate this term and assign it to n, and then pass m and n as parameter to this function, and that would be, equated to these values. The rest of the logic remains the same. So what parameter we pass to R rotate, let the program to execute or perform rotation around the origin or around the fixed point. Now this multiply, what it is doing, now we have called rotate function. This rotate function was supposed to multiply rotation matrix with the original triangle, that is this matrix. Now we have rotate matrix in a function called ROT underscore MAT, array called ROT underscore MAT. Now this ROT underscore MAT, after taking the values of rotation matrix, it is supposed to be multiplied with our object, that is the triangle array. So that is what this multiply does. So this is logic of multiplying two matrices, two-dimensional matrices. So we have taken a matrix called result. We have initialized it to 0 0 0, and into result what I'm doing is I'm multiplying rotation matrix with my triangle matrix. So this is nothing but this is my R and this is my P. P is my object that I have taken. So this P notation is with respect to our 2D rotation video. So if you have not seen it, you can go see it to get the idea of it, right? R is our rotation matrix with theta. Now you have configured R such a way, you have initialized R such a way that it will perform around the origin or around the fixed point. So this multiplies and stores the result of multiplication in result matrix. So now what is my result matrix containing? Result matrix contains the object coordinates after rotation. So after what kind of rotation? Depends on what rotation matrix contains. It can be rotation around fixed point or it can be rotation around origin. Now GL rotate triangle. So this is about rotate. This rotate also performs multiply. After rotation, I am setting my color to green and then I'm calling function draw rotate triangle. So what is this draw rotate triangle doing? Draw rotate triangle is similar to our draw triangle, but instead of triangle matrix, it draws result matrix. What is this result matrix? Result matrix is this, the one which contains the multiplication of these two matrices. So you're just drawing that 0 0 and 1 0 gives us the first point, 0 0 0 1 0 1 and 1 1 gives us the second point, 0 2 and 1 2 gives us the third point. So the third dimension is homogeneous coordinates. It is irrelevant for us in this context. Now see, this is what the complete display function would look like if you want to do both rotation around fixed point as well as rotation around origin together. Now what have we done? This is these two functions. We are doing background coloring and then foreground color to red. We have drawn the original circle in red color and then we have rotated with 0 0. That is, when it is 0 0, m and n becomes 0 0. So these two parameters will be 0 0. That will lead to rotation around origin. And then I am selecting foreground color as green and I am drawing the rotated triangle, the result triangle in green color. After that, I have taken two parameters called as h and k. H and k is my user input, that is the points around which the fixed point around which the rotation has to be performed, and then I'm calculating my m and n parameters. So m and n parameter is nothing but, so xr is taken as h and yr is taken as k. So if you see, h into 1 minus cos theta plus k into sin theta, and the n will be k into 1 minus cos theta minus that is xr, meaning to say h into sin theta. We have taken it and we have passed it as m and n. Now since we have passed it as m and n, that value, these two values will be initialized to m and n, and that will be this rotation matrix with m and n updated values will be multiplied with the triangle, and that multiplication leads to rotation around the fixed point h and k. Now we are selecting blue color and drawing the result matrix again. So result matrix only we are using. So every time we multiply a matrix, we are setting result matrix to 0. So it doesn't matter if we are calling our rotate again. It would give us a new rotated triangle. So I am again writing the result matrix. Over here it will contain the rotation around fixed point result. So that will be drawn, and then I am flashing the output. So this, guys, will give us the complete display function of this program. And this display function actually sets the background color, draws the original triangle, performs rotation around origin, then draws the rotated triangle around the origin. Then it sets the M&N value, that is the translation effect, transformation effect, in the rotation around fixed point, and then I am performing rotation using the updated rotated matrix, that is by passing M&N, and then I am drawing the resultant triangle, and I am flashing the output. So initially in the first slide, what we saw was the basic setup that was needed, but now see, this much is what we had seen. This much was the basic setup for us to execute the OpenGL program. But in this program, we also need user input as theta. So I have taken it as theta, enter the rotation angle, and I have read it as user input. And then the theta that we use over here should be in radians. So what we have done is we have converted it into radians, and then we have taken x and y, that is h and k, as h and k. So that is the rotation around the point around fixed point. Once that has happened, so this will call display function. So the flow of program will now be like, the program will enter into the main, and then it will read the theta, it will read h and k value, and then it sets up the window and everything. It calls the display function. The display function sets the background color, it draws the original object, it rotates and draws the rotation around origin. Again, it rotates around fixed point and draws the rotated triangle around fixed point. So that becomes the flow. Just to give you a recap, we used initialize. These are the header files that we need: gl.h, ut.h, mat.h, because we are using sine and cos, and these are normal C libraries. So we have declared our triangle matrix. Then so you can take any points here for the triangle, it depends on you. And we have taken rotation matrix. Rotation matrix is initialized to 0, and then we have taken result matrix. This is also initialized to 0 initially. We have taken h and k value, initialized to 0. Then you're reading your fixed point by user into this M&N value, because you're computing M&N value according to rotation matrix around fixed point. And then you also need the variable theta. So we'll quickly look at the program. So this is what I have done. I have taken the coordinates as to this, as I have already explained. So these are my initializations. I have written multiply function and then rotate function. Then triangle draw triangle, which draws the triangle matrix. Then draw rotate triangle, which draws the result matrix. And then, as I had explained, so this is the display function. Now this small code snippet here is actually helping me to mark my origin. It can be there, or you can remove that also. It doesn't matter. So if you put it, you get to see the origin. That's it, nothing else. So this is a display function, and then this is init function, and then the main. So this, guys, is the OpenGL program to rotate the object around the origin as well as around the fixed point. Now see, I'll give it as 45, then 200, and then 100. And if you see, this was my origin, as I had already plotted. Now I have removed that code which was helping me to draw the origin, right? Plot the point at origin. I have removed that, so you'll have to imagine it. The center of the window was my origin. I have rotated it around this point by 45 degree, around the origin also by 45 degree. Now we'll try and give some other fixed point. Say I'll give this 100 100. We'll see at 100 and 100. So I'll give 90 degree, and at 100 100. See, this has rotated around point 100 100, somewhere here. Yeah, this would be the point. 90 degree would be there, right? And this is rotated around origin, something like this. So this is, guys, is the implementation of OpenGL program for rotation. Thank you, guys.